Continuing our discussion of creating Metasploit modules, let's have a look at our earlier exploit Python script. We started out by setting a host IP and a port, and then we said if you don't want to use those, you could pass something in on the command line. And then the exploit itself sent trun space and then a period, followed by 2006 A's. That was followed by the address of a jump ESP instruction. And recall that these addresses are stored in little endian format. So this address is really 625011AF. Then we gave it 16 no ops, and then finally our payload. Once we built this string, we created a socket, then we connected, and then we sent our data, but first we got the banner. We printed that out, and then finally we sent our string. That's a fairly straightforward exploit. How does this look inside a Metasploit module? So for my Metasploit module, I have to populate certain things. Now, a lot of this stuff is optional. For example, the name, I set to vuln server trun. Description was trun command, vulnerability for vuln server. You can set license, you can set an author, and under the author category, there's a listing for who discovered this vulnerability. I just put unknown because I don't know who did. Who made the module? I did. And then there's a section for references. So if this is a publicly disclosed vulnerability, you can put in the various numbers from OSVDB, CVE, and you can also enter a URL for people to get more information. All of this stuff is optional. It doesn't really affect how it runs. Then you have the exit function. The default is process, but you can have an exploit that exits via thread, SEH, etc. The platform is Windows. And then what about the payload? Notice we've disconnected the payload from the exploit by using Metasploit. So for the payload, I have to tell Metasploit if there are any bad characters, things that will make this fail. And in many cases, those bad characters will be 00, which is the null value. So if I'm using stir copy, it will stop. 0A and 0D, which have a tendency to be interpreted as an end of file. Then I have an option which says disable NOPs. Don't allow me to add NOPs into this payload. Normally, you want that set to false. Then we have a section for targets. What are the possible targets for this attack? There's just one, vuln server 1.0. Here we have some of the most important information. What is that jump ESP address that I need to get loaded? And here I have 625011AF. Compare that to my original script. In my original script, I had the value in reverse order, 625011AF. So this is in fact the same value. It's just stored as one address and it's not a bunch of separate bytes in little endian. The other important bit of information, the offset. How much data do I need to generate before I input this return value? 2006 characters. Again, if you compare to our script, I was padding with 2006 A's. It's not a privileged command. There's also the ability to enter some date information for when it was disclosed. This hasn't been disclosed necessarily. Then you have the actual exploit. Under def exploit, this is Ruby's way of defining a function. In this case, the function is called exploit. And here is how this exploit works. If you look at the logic in the script, the first thing I do is connect to the socket. Then I have to build a command. So I'm going to build up a buffer. It starts with trun, period, with a space in between. Again, compare trun, period. Then I have 2006 characters of padding. So here I'm using rextext.patternCreate 2006 plus I need to put in that address. That address is stored in target.ret and I will pack it in VAX format, which means little endian. All that this does is it turns my address back into this form here, where it's sending it in little endian format and it's reversing these bytes. What comes next? 16 knobs and then my payload. So here in my Metasploit script, I call make knops 16. Now, in the case of my script, I used 16 actual knops. What we'll find is that Metasploit has a couple of different things, all of which are equivalent to knobs. Finally, I add to that my payload. And my payload's been encoded, and that payload was selected by the user. I print out a message trying the target. I put all this out on my socket. I call handler. Handler's been set up in order to handle what happens next. And again, this is a standard thing. I don't have to write. I disconnect. That's it. This method ends and this entire class ends. So we're going to take a brief break. And when we come back, we're going to show you how you can actually do this exploit in Meterpreter.